Hello dear students. So we'll move on to the last topic of first module. So we'll be seeing surfaces orthogonal to a given system of surfaces. അപ്പം നമ്മൾ കണ്ടുപിടിക്കാൻ പോകുന്ന suppose you are having a given system of surfaces. So you have something of the form f of x, y, z equal to c. So when c takes, so c is arbitrary, so that will give us a family of surfaces. If you have a family of surfaces, we are going to find another family of surfaces such that these surfaces intersect at right angles, or they intersect orthogonally. So തന്നിരിക്കുന്ന സിസ്റ്റം ഓഫ് സർഫസസിന് ഓർത്തോഗണൽ ആയിട്ടുള്ള വേറൊരു സിസ്റ്റം ഓഫ് സർഫസസ് നമ്മൾ വിൽ ലുക്ക് അറ്റ് ഹൗ ടു ഫൈൻഡ് ദാറ്റ്. Okay, so we'll start with a one parameter family of surfaces. So you are given a system of surfaces f of x, y, z equal to c, and we are going to find a system of surfaces which cut each of this given surfaces at right angle. So തന്നിരിക്കുന്ന system of surfaces orthogonal ആയിട്ടുള്ള വേറൊരു system of surfaces കണ്ടുപിടിക്കുകയാണ്. So we'll look at how to find the system of surface. So we are again going to use the simultaneous differential equation to find these surfaces. So the surfaces will be obtained as the integral surface of a first order PDE. So we'll look at how do we get that. So the normal at the point xyz to the surface. So you have the surface f of xyz equal to c. ഇനി അതിൻ്റെ നോർമൽ എന്ന് പറയുന്നത് ഗ്രേഡിയൻറ്റ് വെക്ടർ ആയിരിക്കും. സോ ദാറ്റ് ഇസ് എ വെക്ടർ ഡോ എഫ് ബൈ ഡോ എക്സ്, ഡോ എഫ് ബൈ ഡോ വൈ, ഡോ എഫ് ബൈ ഡോ സെഡ്. നൗ if the orthogonal surface, so let me take the orthogonal surface to be z equal to phi of xy. Okay, അപ്പോൾ orthogonal surface ൻ്റെ നോർമൽ എന്ന് പറയുക that will be so you can write it as phi of xy minus z equal to 0. So the normal vector is in the direction dou z by dou x, dou z by dou y minus 1. Now രണ്ട് സർഫസസും ഓർത്തോഗണൽ ആയതുകൊണ്ട് the normal vectors will be perpendicular. So from this we will get dou f by, so dot product എടുക്കുക, dot product എടുക്കുമ്പോൾ you are going to get dou f by dou x into dou z by dou x plus dou f by dou y into dou z by dou y equal to okay minus dou f by dou z വരും. dot product എടുക്കുമ്പോൾ that will be equal to 0. So I am taking it to the right side. So you are going to get plus dou f by dou z. Now I need to solve for z from here. So I am getting the equation dou f by dou x p plus dou f by dou y q equal to dou f by dou z. Okay, so here this is an equation satisfied by the surface z equal to phi of xy. So therefore the surface is orthogonal to the given system of surface will be the solution of this first order PDE. So this is a first order PDE in the form PP plus QQ equal to R, where P is dou f by dou x, Q is dou f by dou y, and R is dou f by dou z. So therefore the orthogonal surface is obtained by solving the equation, solving this first order PDE, or the orthogonal surface is generated by the integral curves of dx by p, that is dx by dou f by dou x equal to dy by q, and dou f by dou y equal to dz by r, so which is dou f by dou z. So we'll see a few problems. So find the surface which intersects the surfaces of the system z into x plus y equal to c into 3z plus 1 orthogonally, and which passes through the circle x square plus y square equal to 1 and z equal to 1. Okay, we need to find the orthogonal system of surfaces to the surface z into x plus y equal to c 3z plus 1. ഇനി നമുക്ക് ഇവിടെ കണ്ടുപിടിക്കേണ്ട പെർട്ടിക്കുലർ സൊല്യൂഷൻ ആണ് കണ്ടുപിടിക്കേണ്ടത്. സോ ഫസ്റ്റ് യു ഫൈൻഡ് ഔട്ട് ദ സർഫസ്. നൗ ഫ്രം ദാറ്റ് ഐ need to find the particular surface which passes through the circle x square plus y square equal to 1 and z equal to 1. Okay, so here f of xyz equal to c is this equation. So I am writing in that form. The f of xyz equal to c എന്ന് പറഞ്ഞ ഫോർമുല എഴുതുന്നു. അപ്പോൾ z into x plus y by 3z plus 1 is equal to c. Now you calculate the derivatives, dou f by dou x, dou f by dou y and dou f by dou z. So that will be obtained as, so z by 3z plus 1, dou f by dou y is z by, again z by 3z plus 1, and dou f by dou z is x plus y by 3z plus 1 whole square. So we'll get dx by z by 3z plus 1 equal to dy by z by 3z plus 1 equal to dz by x plus y by 3z plus 1 whole square. So 3z plus 1 will cancel off. So that will give you the equation. So here you will get 3z plus 1. The cancel I can remember 3z plus 1. I am multiplying 3z plus 1 throughout all the terms in the denominator. So that will give me dx by z into 3z plus 1 equal to dy by z into 3z plus 1 equal to dz by x plus y. So obviously the first solution is obtained using the first two ratios. You will get dx equal to dy. So which gives x minus y equal to c1. And for the second, okay, but x plus y under, but for the second solution I'll take dx plus dy. So in denominator you will get 2z 3z plus 1 equal to dz by x plus y. So cross multiply. So you are going to get x plus y into dx plus dy equal to 6z square plus 2z dz. So on integrating you are going to get x square by 2 plus when you open the brackets you are going to get x dx plus x dy plus y dx plus y dy. So which has an exact integral, that is x square by 2 plus y square by 2 plus x plus y. And on integrating this you will get 2z cube plus z square plus c2. So that gives me the second solution. So therefore these two integral curves will generate the integral surface. So ini namukku kandupidikenda, we need to, so we have got the integral surface. Now we need to find the integral surface which passes through the circle x square plus y square equal to 1 and we have z equal to 1. So on substituting z equal to 1 substitute cheya, and here z equal to 1 kodukka, x square plus y square equal to 1 substitute cheya. So from the second solution you will get 2xy equal to c2 plus 5, and first equation you will get x minus y equal to c1. Now by using this relation x minus y whole square equal to x square plus y square minus 2xy, so I can eliminate xy. Okay, so you will get a relation involving c1 and c2. So x minus y whole square is x square plus y square minus 2xy. So if you take x minus y whole square, that will be equal to c1 square. So c1 square is 1 minus 2. Okay, 2xy is c2 plus 5. So that gives me the relation c1 square plus c2 equal to minus 4. Now substitute back c1 and c2. So on simplifying, you will get the orthogonal surface passing through the given curve. So that is x square plus y square minus 2z cube minus z square equal to minus 2. So we will see another problem also. Find the surface which is orthogonal to the one parameter system z equal to c into xy into x square plus y square, which passes through the hyperbola x square minus y square equal to a square and z equal to 0. So first of all, find f of xy z. So f of xyz is equal to c. So that gives f of xyz as z by x cube y plus x y cube equal to c. And now you need to find the partial derivatives dou f by dou x, dou f by dou y and dou f by dou z. So find the partial derivatives. So dou f by dou x is minus z into 3x square y plus y cube by x cube y plus xy cube whole square. അതുപോലെ dou f by dou y minus z into x cube plus 3xy square by x cube y plus xy cube whole square, and dou f by dou z is 1 by x cube y plus xy cube. So, the orthogonal surface is obtained as a solution of the integral equation of the differential equation dx by fx equal to dy by fy equal to dz by fz. For fx, fy, fz value substitute ചെയ്യുക. ഇനി എല്ലാ ടേംസിൽ നിന്നും x cube y plus xy cube cancel ആവും. Just in the first two terms, I have taken the common terms outside. അപ്പോൾ y cancel ആകും, ഇവിടെ x cancel ആവും. Okay, so I am multiplying x square plus y square by z, that is common in these two terms. So I am taking it to the third term. So you multiply the denominator by each എല്ലാ ഡിനോമിനേറ്ററിലും x square plus y square by z കൊണ്ട് multiply ചെയ്യാം. So I will get in this form. So once I simplify the equation, this integral equation, so I am going to get in this form. Now let me choose the multipliers x, y and 4z. So when we take the multipliers x, y and 4z, so pp dash plus qq dash plus rr dash is equal to 0. So you will get the equation x dx plus y dy plus 4z dz equal to 0. So on integrating, this gives x square by 2 plus y square by 2 plus 2z square equal to c1. So that is the first solution, x square plus y square plus 4z square equal to c1. Next we need to find the second integral curve. So I am taking these two ratios. So x dx minus y dy by, I'll get minus 2x square plus 2y square equal to x dx plus y dy by minus 2x square minus 2y square. So on simplifying, I'll get as, so cross multiply here, so 2x dx minus 2y dy by x square minus y square equal to 2x dx plus 2y dy by x square plus y square. So on integrating, you are going to get the solution as x square minus y square by x square plus y square equal to c2. So therefore, these are the two solutions. Now we need to find the integral surface which passes through the hyperbola x square minus y square equal to a square and z equal to 0. So z equal to 0 substitute ചെയ്യുമ്പോൾ you are going to get x square plus y square equal to c1 from the second equation, and ഇവിടെ x square minus y square a square substitute ചെയ്യാം. So that will give me the equation a square. Okay, so you are going to get c1 c2 equal to a square. So this is free from x, y and z. So now substitute back c1 and c2. So that gives me the particular integral surface which passes through the given curve. So hence this is the orthogonal surface to the given family of surfaces. Thank you.